So, how do we get an AI to not just give an answer, but to actually think its way to a solution? I mean, that's one of the biggest hurdles in AI today, right? But what if the very tools we're using to teach AI how to reason have a secret flaw? Well, today we're going to dig into this really cool discovery where a super simple, kind of elegant fix led to a massive jump in AI performance. It's wild.
Okay, so the main problem we're trying to solve here, it isn't just about getting the right answer. It's about getting an AI to actually show its work. To lay out a logical step-by-step process, just like your math teacher always told you to do. And that's absolutely crucial if we're ever going to really trust and understand these systems.
So how do we actually do that? Well, one of the main ways is a method called reinforcement learning with verifiable rewards. Yeah, RLVR for short. The easiest way to think about it is like training a dog. The AI tries to solve a problem, and when it gets the answer right, boom, it gets a little treat, a reward. And over, it learns that to get those rewards, it needs to generate these longer, more detailed, and really logical explanations.
But here's where things get tricky. A really subtle problem started to creep into the system, something the researchers are calling a length bias. It's the sneaky, unintentional flaw in the training that was quietly messing up the AI's ability to think deeply.
And this analogy just hits the nail on the head. Imagine a teacher who, without even realizing it, starts giving slightly better grades to shorter essays. What's going to happen? Well, the students are going to start writing less, right? Even if it makes their work worse. That's exactly what was happening here. The AI started learning the wrong lesson. Keep it short, even if it means you're not actually explaining your reasoning.
So you can really see the conflict here. On one hand, what we want is to reward the AI for correct and super detailed reasoning, no matter how long it takes. But on the other hand, because of this length bias, what was actually happening was the system was giving bigger rewards to shorter answers. It was punishing the very detailed thought process we were trying to teach it. Kind of crazy, right?
Now, this whole length bias thing was pretty subtle, and it might have just stayed a minor issue. But then, a new, more advanced algorithm showed up, and it accidentally poured gasoline on the fire. It turned this small problem into a full-blown crisis for the AI, leading to something called response length collapse.
Okay, so this new algorithm is called GSPO. And look, it was designed to be a big improvement. Its whole purpose was to make training more stable, more efficient, especially when you're dealing with these absolutely massive models. It was a really smart idea, a step in the right direction, but it had this one side effect that nobody saw coming.
See, the way GSPO calculated its rewards and processed all the data, it ended up massively amplifying that little length bias we talked about. And the result? The AI's answers started getting shorter and shorter and shorter. It was basically learning that being brief was the most important thing, no matter what. And this chart, wow, it just says it all, doesn't it? Take a look at that blue line. That's GSPO. As the training goes on, you can see the length of the AI's responses just taking a nosedive. It's literally forgetting how to think out loud. And if you look at the orange line, which is the older method, it was actually doing what we wanted, encouraging longer answers. That blue line, that's response length collapse, right there in front of you.
But don't worry, the story has a hero. Thankfully, some very smart researchers came up with a really elegant solution. It's called LUSPO, which stands for Length Unbiased Sequence Policy Optimization. And yeah, this is what's going to save the day.
And what's so cool about LUSPO is just how simple it is. So remember the problem with GSPO? By averaging the rewards, it was basically making each step in a long, correct answer less valuable than each step in a short one. So what was the fix? You're not going to believe this. All they did was scale the reward by the length of the response. That's it. Just a simple multiplication, but it was an absolutely game-changing fix.
And just like that, with that one little tweak, the entire incentive system flips. All of a sudden, the AI isn't being punished anymore for thinking out loud and giving detailed answers. In fact, now it's being properly rewarded for every single correct step it takes, no matter how long the explanation is.
Okay, so that all sounds great in theory, but did it actually work? Well, the proof is in the pudding, right? The researchers put LSPO to the test, and let me tell you, the results they found were a huge breakthrough.
And just look at this. The evidence is so clear. On the left, you've got that chart we saw earlier, with GSPO's response length just collapsing. But now look at the chart on the right. That dark blue line for LUSPO, it's not just stable, it's shooting straight up. It totally fixed the problem and got the model to start reasoning in more detail again.
So what does that mean for how well the AI actually performs? Well, check out these scores from the AIME benchmarks. These are basically super hard math competition tests for AI. And using the exact same model, just switching from GSPO to LUSPO, the scores just jumped. It's such a clear, dramatic improvement in its actual reasoning skills.
I mean, let's just pause on that for a second. A 17.1% gain on one of the hardest math reasoning tests you can find. That is not a small improvement. That's a fundamental breakthrough that came from fixing just one hidden problem.
And get this, it wasn't just for text-based math problems either. LUSPO worked great for multimodal models. You know, the ones that have to understand both text and images. It got way better at solving logic and math problems that involved visuals, boosting its scores on tough benchmarks like WeMath and Logic Vista.
So let's zoom out. What's the big takeaway here? This whole discovery isn't just about one algorithm. It's a perfect example of why finding and fixing these little hidden biases is so important for the future of AI.
Because at the end of the day, this was never about just making the AI's answers longer just for the sake of it. The length was just a symptom of a deeper problem. The real goal, the whole point, is to protect and improve the AI's ability to do complex, step-by-step thinking. And LUSPO works so well because it lined up the training process with that true goal.
And honestly, this quote from the research paper just wraps it all up perfectly. By making a simple, length-aware adjustment, LUSPO fixed the bias. And that made the training more stable and made the model perform way better. It just goes to show you how a small, smart change can make a massive difference.
And that really leaves us with a big question to chew on, doesn't it? Finding this hidden length bias really makes you wonder, what other tiny, almost invisible biases are lurking in the way we train AI right now? And how might they be shaping the future of this technology in ways we can't even see yet?